Welcome. In this video we're going to introduce the concept of what a vector is, and we're going to just spend a little bit of time understanding what these things are, how they work, and how we can start to consider them mathematically. We're not going to go too deep today. We're just going to get our head around a few concepts. So fundamentally, when you think vectors, the picture that you should put in your head is essentially an arrow, and the thing that defines an arrow is essentially how long it is, so its length, and what way it's pointing, so its direction. And we can draw another arrow of the same length, just make it the same color, shall we? Same length and same direction, and these two things are the same vector. Doesn't matter that I've drawn them in different spots, because they have the same length and the same direction, they're the same vector. Now we can have vectors in 2D, i.e. you can imagine drawing your vectors on a piece of paper. So here we go, so we could have two-dimensional vectors, and once again I'm drawing a whole lot of copies of the same vector, at least they're supposed to be. You could probably measure them and find they're not quite exactly right. So we could have vectors in 2D, or we could have them in 3D. So now we're imagining, instead of just being on a piece of paper, we're inside a box, and this vector could be somewhere inside this box. So long as it's pointing the same way, doesn't matter where it starts, it's the same vector. Right, so that's all well and good, and it's a nice and accurate mental picture of how vectors work, but there are a couple of flaws. If we want to start doing some mathematics on these, we don't have any numbers involved here at the moment, we've just got arrows, so we can only go so far with this approach, so we're going to need to introduce a way of mathematically describing them, and it'd be nice if we could generalize our vectors to go higher than 3 dimensions. Now obviously in terms of visualizing things that doesn't make a whole lot of sense, but there are lots of good reasons why we might actually want to use vectors that have higher dimensions, and it's not just all esoteric weird stuff. There are lots and lots of good reasons why we might want to do this, and we'll introduce you to those a little later in the course. Okay, so the first thing we want to do is let's pin down some maths. How do we actually get some kind of mathematical reference for describing these vectors? I'll work in 2 dimensions because it's easier to talk about. So first thing you want to do to put some numbers to a vector is to define some coordinate axes. And normally we call them x and y, but sometimes we call them different things. Just be aware of that. So if I were to draw my vector on these axes, doesn't matter where I start it, maybe here, the way I can put some mathematical context to this is by measuring how far I go in the x direction. So let's say, so I'm going this way in the x direction, I'm going right, and I'm going up. So I could measure this distance, and let's just say, for sake of argument, that that length along there is 3. And that this length along here is, say, 1.5. Because I'm going right, I could, and I'll give this vector a name as well, u. I'll underline it when I'm handwriting it, and I'll make it bold when I'm drawing it, typing it up in a worksheet or something. I could say that this vector u is equal to, here's our notation, 3, I put my x component first, and then 1.5, I put my y component second. So x component first, the numbers are called components, and positive means right. And then second, I'll put my y component. And for the y component, if it's positive, it means it's going up. And again, you can see by this way of constructing these vectors, this one here is exactly the same because it has the same x component and the same y component. Doesn't matter where I drew it. Let's just practice one in a different direction just to get used to using negative numbers as well. So let's say I were to draw this vector here. You can see it's going downwards by 1, for example, and let's say it's going left by 1 as well, and I'll give this one the name v. It's quite typical to use letters like u, v, and w to describe vectors. So v would be the vector x is -1 because it's going left, y would be -1 because it's going down. Now, vectors are very closely related to things that you've probably looked at before called points. So a point is just literally a point in the plane. So you might be used to writing something like this. You put its x component first, then its y component. that might be the point 3, 2. Down here might be the point negative 1, 1. Now if we make a special rule that we make our vectors start at the origin, okay, this point here, which we often write as an underlined O, is called the origin. If we make it a rule that we start our vectors at the origin, then you can see that this vector here is the vector 3, 2. And you can see it's got the same numbers in it as that point. So we say that this vector is in reference position. Okay, so this vector in reference position. So a vector is just in reference position if its tail, okay, that's the starting end of it. This is also called the head. If its tail is at the origin. So you can see that any vector in reference position will have the same numbers in it that the corresponding point has. Now this is actually really useful because quite often when we're talking about, let's say, a curve or some kind of curve in the plane there, you can think of a curve as a collection of points, and the math that we're going to develop on vectors can be really useful sometimes for describing things like this. So being able to make a correspondence between these vectors and points is a really handy thing to do. So if we want to talk about points in the plane, we're often going to use vectors in reference position as a way of doing this. Now the last thing that I want to talk about is how do we deal with, say, 3 dimensions or even higher. So let's just draw a sketch of some 3-dimensional axes. So we'll have 3 axes here. Here's my x, here's my y, and here is my z. And I want to put, let's draw a vector in reference position in 3 dimensions. Here it is. How do I write down the components of this vector? Well, let's just draw in a little bit of context here. So I can drop down to the xy plane a certain distance. Let's just pretend it's 1. And then I can come in parallel to the y-axis, another distance. Let's just say it's 2. And then let's pretend it was 3 from that point there, which again is at right angles, back to the origin. So this vector here would just be u equals, so x component first, 3, y component second, 2, it's positive, it's lined up with the positive arrow on the y-axis, and then 1 for z. So my vector generalizes really nicely. And again, I've drawn it in reference position, so it also corresponds to the 3-dimensional point 3, 2, 1. This is a 3D vector. And there's no need to stop at 3 dimensions. We can talk about higher dimensions. We could have a 5-dimensional vector like this if we liked. 1, 2, 5, 0, -1. And that has meaning. Obviously we can't visualize it, so don't get too hung up on trying to conceptualize visually what that means. Our brains don't cope very well with that. But as you'll discover in this course, there are lots of reasons why we might want to work with vectors in higher dimensions and why that's a useful thing to do. But for now, we've got a picture of a vector. We know how to draw it on some axes and that it means an arrow with a direction and a length. And the other thing we need to know is that a vector in reference position, that means starting from the origin, let's just draw our origin on this picture here to make it complete, corresponds to a point in that space. So we have this way of converting between points and vectors should we so desire.